All right, let's discuss the important matters.
I used to have the link, but now I'm lost again. So just pick it up again. Here we go. Public refresh to perfect.
Should we dim the light a little bit, or it's all?
Oh, we fucked it up again?
No?
No, I think it's the same one as before. Like it doesn't get any better.
We all just want to go to sleep again.
So I think last time when we talked about this, we basically said like, ideally for the streamer, we just take basically deflate stream or.
That's exactly what this is. Yeah.
So the only thing is like you have these guys here, the buffer sizes, which
Yep.
the other one doesn't have. So we're going to talk about that.
Yeah. So that we could take it or leave it. I'm not sure how much value it's really going to have. So if we want a smaller API, we can just knock those off.
So I have a question. Could we make it into a property?
Yeah.
Like what would happen if you change it? What would we do if somebody changes it after the stream was
Yeah. So
created?
that would be the problem. I guess then we would have to flush the buffer essentially to the underlying native implementation if we reduce it such that we would curtail the data otherwise. So I mean that would be doable. I'm not sure if anyone would want to do that though.
Well, it's not that whether somebody first, like what would we do? Not whether somebody would want to do it, but like we would have to have some reasonable behavior. So let's say I create a stream.
Mm-hmm.
Don't use it yet. I just created an instance. If somebody now sets the property, would it be reasonable? Would you have to do anything with flashing the buffers and copying?
No, not if there's no data in there.
No, because you don't yet create the buffer till somebody starts using the stream. So when an instance is created, it's empty. It's just like, it has the settings. So then they could freely change the property, and when they started to use the stream, it would all work.
Yeah.
We would just have to come up with something to do when they start using the stream, then they change the property.
Yeah, in that case, we have to do the flushing.
Well, there are types in the framework that don't allow you to change them once they.
Yeah. Mm-hmm.
Yeah. Or we could throw an exception.
Because it would probably be easier.
Yeah. It would certainly be easier. Yeah.
Because you see, like that would kind of solve the problem. So now we have like 6 constructors. We would go back to 4. And also, if it's a property, like if you don't care, you don't see it.
Yeah.
Versus constructor parameter, it's kind of in the face. Once you like start looking at the constructor, it shows you IntelliSense shows you the signature.
Is it only used for compression or also decompression?
I believe it's used for both. I think probably the best way to go about it would just be to copy deflate stream's API, get rid of the buffer stream for now, and then later we could add the property.
Or constructor, if we decide.
Or deflate stream as small as possible.
I like it.
Cool.
Yay, stream done. Now for the longer one.
Is this everything we had? I mean, this was the first thing. I think the only thing we actually covered before the meeting went out of time.
Yeah, I also I've asked earlier, but you weren't here to answer. What are the semantics of flush on this API?
I don't care what.
For Brotli stream or for the Brotli encoder?
Either. Well, stream, since that's what we're looking at right now.
So for the stream, it's pretty much the same as deflate streams. It'll act the same way. The only thing about Brotli, which is different from deflate, is that a Brotli stream isn't really completely inflatable unless you have the finished byte. So like for a deflate stream, for example, you could encode half of it and then give it to an inflator and then call it a day. Yeah. But for a Brotli stream, you need to do the finalization first. And if you don't do the finalization, then it's not going to have that final byte. And the inflator Google/Brotli, that one will actually throw if you give it like partially compressed data.
Okay.
So it's as similar as it can be, but you still need to do a dispose.
I see. So basically, dispose is the way to tell the API I'm done.
Yeah. Our finalization. Other than that, it's all the same.
I just removed all the overrides and suddenly it becomes.
So here's a particular scenario that I'm thinking of. Say that I'm writing a large document to the output stream, and halfway through I say flush, and then I send that off to a receiver somewhere. As that receiver runs it through the decoder, is he actually going to be able to see all of the document that I've compressed thus far? or is there going to be some type of buffering that he won't be able to work around?
As long as you haven't hit the end of the data that you want to encode, then it should be doable.
Yeah, let's say that I sent half of it.
Yes.
I ran half of it through the encoder, I said flush,
Mhm.
I got some output, and then I just sent it right across the wire.
Yeah. And we've got some tests for that too.
Because that's what I mentioned in email earlier about like real-time streaming scenarios.
Yeah.
Okay.
Alright, so this is what we have. So far, everybody's in agreement? Should not come with any surprises.
Do we want to do the? Oh wait, no. Then yeah, that's right.
And then the base trim is the same as both
Uh-huh.
deflate and gzip, so that's
Yep.
just expose that puppy.
So, is that the buffer size? I thought that it was supposed to be a property, right? Or no?
I was thinking we should leave it off for now and maybe just add it later.
Okay, sorry.
Yeah.
Missed the part. Thanks.
It's inconvenient to set it afterwards.
Yeah.
Alright, so the usage is okay, so then the decoder.
So we had some internal discussion. We had an email thread floating around for changes. So this changed pretty recently. I updated it, and I added some design questions we were having at the bottom. There's sort of like three main questions.
So, do we already have operation status in the? It already was added.
Yeah. Some sort of like conditionally approved about it, but it's in there, so
It's not conditionally approved.
okay.
Interestingly, recently Aston discovered that there's already a type called operation status in the framework.
Or like operation result or something like that.
He said that it's operation status.
So operation status didn't go through this API review, as far as I know.
Yeah, that was.
So even if it's in system memory, it might be the like, yeah, we are working on it.
I'm pretty sure that it went when we reviewed base 64 APIs.
Sure about
It
that?
was in the it was in the signature of the API, so
And it's in there now.
Well,
but the name, renaming it, but it's a separate review anyway, and I forgot about that it's already there. And this API would depend on system memory.
Yes.
Okay. Yeah, because I was kind of thinking if this needs to be lower in the platform than system memory, we cannot use operation status.
Yep.
But I think we are good because
We probably should.
you're gonna be on top of this one. You're not adding it. What assembly does it go into?
This is its own right now, but we could put it in system IO compression if we wanted.
So so if we put it in system I/O compression, then we have a problem with dependencies.
Yeah, so right now it's in system IO compression .brotli.
why do we have?
Well, because operation status is in system memory.
Yeah. Why cannot be at the edge dependency? Like I/O compression is not lower under system memory, right? So you will not
Yeah,
get
parallel
the
to it.
cycle.
Well,
You want to lift it up, or that's the reason, or
today we don't have a dependency from system compression to
Yeah.
system memory, and we would be adding dependency, and I don't fully understand what it would mean.
Okay.
Like we already like.
so it's a general fear, which is fine.
It's
you
the
know, we
OOB.
just want to
It's
understand.
basically the issue with the OOB and implat.
I/O compression is special because it ships, on the side as well. So, as a pure OOP.
Well, it's pure OOB and it's built into the .NET framework,
Yep.
which makes it.
It's the combo.
It's already like.
That baby we should not touch.
Yeah, I mean, it's perfectly fine in its own assembly.
What?
The definition of not being a pure OOP, but yeah.
Yeah. Okay, so I think we can make it work if it's purely on top. So what's the plan for networking stack? So if we ship it on top of the platform, networking stack cannot take dependency on it, correct?
What do you mean by on top of the platform? You mean not a part of the platform?
As an
So the
If
current plan
this
right now is to
component-
put it in the platform. So it'll be a part of Microsoft Netcore app. We're not thinking we want to OOB it, especially because it has a native dependency.
all right, Imo, you need to decide whether it's how we do it. I'm already.
Because what's the benefit to OOBing it?
So I would say let's first look at the APIs and then let's talk about Ubing so we make it into the API.
Sure.
Because I think Ubing may be a lot of, Ubing, how we ship it is like not really blocking you right now versus the APIs kind of are. So let's finish that maybe first.
The point is not benefit from this ubing or not ubing, is that system memory.dll is an ub.
Right.
So if you have a dependency on system memory, I assume you are ub. You see, this is where I'm getting
Yeah.
confused now.
So I think there was this idea that ASP.NET wants to use Brotli, so it has to be in 2.1.
Yes.
Expand is in 2.1, right? So like that doesn't prevent, like he doesn't have to be OOP just because span is OOP, right? It just means that the inbox version, you cannot have an inbox version when the underlying span is not inbox.
You need to run as well on framework.
Right. Well, that's a whole
That's
different
a whole
thing.
different
Yeah.
ballpark.
This is the other thing. Again, we can't change physics. If they want to run in 4.6.1, well then, yeah, that's what it is.
Oh, and memory targets like 461 as well
Right.
can, right? So I wouldn't be shocked if they want Brotli in the same boat.
Well, everybody wants everything.
It's fair. Let's do the API, but I think it would be good to talk more about where it ships and the relationship with various existing
Yes.
dependencies, because this OOP thing is super scary.
Yeah.
And
I
don't-
talked about this with Wes and Josh separately, and sort of what we thought would be the best route would to not OOB it unless we have a fully managed implementation, because the native dependency makes things complex. So we would just require ASP.NET to upgrade.
Mhm. So, and now if we don't OOB it, system memory. Because
Where would it fail? Would it fail in packaging? Would it fail in building? Where would the problem
non-OOP
arise?
components cannot depend on OOP components. Do you agree?
I don't know.
Yes.
I guess.
So if system memory is OOP, this thing has to be OOP if it depends on it.
In other words, inbox cannot depend on things that are not inbox.
Yeah.
Right? There's just physics involved with what APIs you can call. But
And operation status, so system memory is like a hybrid component, like part of it is in the platform, part of it is just OOB.
Yeah.
I think operation status is just OOB. Like basically we don't have APIs in the framework that return it. We only moved into the platform, span, read-only span, and kind of its dependencies.
Well, I definitely don't feel that operation status should modify our decision on OOB versus not OOB, because operation status is just an enum. We don't need it. It's not like before this. I had Brotli result, and it was the same thing.
But anyway, let's go through API first, and then we can.
Alright, so I did some minor cleanup. So I moved the statics to the bottom, so it's easier to see the difference between the static and non-static use.
Sure.
So my first question would be you should probably follow the normal dispose pattern here, where you would have. Well, I guess it's a struct, doesn't matter.
Yeah.
Keep forgetting it's a struct.
I have some variations down below it in the issue also. Mostly just naming stuff, but
So when does decompress fully return false?
if it has too much data to put in the destination span, or if it fails because the input data is invalid.
So it will never throw them, ever.
It won't throw, no.
So it should be called try.
Yeah, that's one of the variations down below. Try decompress fully, or try decompress single, or try decompress data, or try decompress any of the above.
So before we go there, my first question is disposable and structs. So what does it happen when you copy the struct around and you call dispose one of the instances? The other ones are basically defunct at that point, right?
Will they all get disposed
Yeah.
at that point?
Well, but the problem that you have today is when you have, let's say you have two classes, or sorry, you have one class, right? If I call dispose on that guy can basically register that you called dispose, and null out any pointers, and then effectively when you call another method just throws not supported because you disposed it.
Yeah.
If you have two structs and let's say they hold on to native memory. If you dispose one of them, well, you can clear up the pointer for that guy. But the other one still points now to memory that no longer exists, so you crash in the next
We'll
one.
have a safe handle though, yeah.
Yeah, this one holds to a safe
So,
handle.
so the sort of the difference there is that this is a struct, but it's not entirely non-overcoding. It has a safe
So
handle inside of it. So you can copy it and it's fine.
So what ends up happening is when I call dispose on one of the structs and call methods on the other one, what ends up happening, I just get like a
Object disposed.
It'll throw an object disposed. So it'll try to reference that safe handle that's now been
We have
disposed.
tests for that.
Yeah, oh yeah.
so the behavior is what you would expect it to be.
Yeah.
So how do I? Let's say I'm using the decompress method, not the decompress fully.
Sure.
Yes.
How do I say that I'm done? Dispose?
Yes.
And that's the only way to say I'm done,
Yes.
correct?
You're thinking of like flush or something, or
Well, mainly I was just asking like how you do it. I'm not sure whether it's so in a lot of other APIs, and Levi, you kind of worked on similar, where you call like decompress first chunk, second chunk, third chunk, and then you call decompress final, or like an API that is called final.
yeah,
And it makes it very explicit. Like you look at the API and you know. Here it's kind of like you have to know that you should call dispose.
Side
Which
effect.
maybe it's okay.
It's a little bit different too because Brotli knows when it's done. Like there's bytes in the decompressed data that'll say this is the end of the input. So
Oh yeah, you're right. It's only for the encoder.
yes, it's only for the
That's
encoder
it.
that you need sort of flush or flush corollary.
Okay.
Like I think Ian, what you've done here is you never actually have to call dispose except as a perf optimization because, as you mentioned, the decoder always knows when it's done anyway, and the encoder requires a caller to call compress final at some point.
Yeah.
So
I see.
I mean, the way I have it written right now is to require dispose, but we could certainly do an actual dispose whenever the decompress is done with it.
wait, you require calling dispose?
Yeah, that's how you get rid of the native pointer.
No, but I mean it'll get GC though if you.
Oh well, yeah. It's just that's the pattern.
Yeah.
Well, it will get GC, then the finalizer on the safe handle will close.
Yes, that'll close it. Yes.
Yeah.
But what I meant was that you're not relying on the call to dispose to generate the correct stream.
Oh no, because that'll be done by decompress or it'll be done by compress final.
Right.
so then I guess the difference in decompress fully is that fully assumed everything fits into the buffer.
Yep. And then you don't need an instance of the decoder.
So what did we end up with the other APIs? We ended up calling them try decompress fully, I suppose, right? Or whatever the other ones were.
On what?
This API, like in other places, like we had like a decode or something. We would call this fully try decode, right? So this would be try decompress fully, I suppose.
But I also commented it in the email, and maybe it's a good thing to talk. Like I think the fully suffix is not necessary. I mean, we don't like most APIs unless they say otherwise. They do what they say. So I would just call it try decompress.
Do you think there's enough distinction there between the static one and the non-static one with just try decompress? That was my worry for adding the fully.
Well, you won't in IntelliSense. You won't see a static extension method when doing dot on an instance, so that will be hidden from developers for the most part. Assuming that we're relying on IntelliSense.
We do. For discoverability, that's the primary way people will find APIs.
But even if not, like when you look at this API, I mean, there's a static method and it takes source and destination, and like what else could it do?
It has to decompress everything in source and put everything in destination. I mean, there's no. I mean, the contract pretty much disallows continuous usage.
I would, like if we worry about people not understanding, I would rather add the suffix to the first one. Like basically say like decompressed chunk or something like this.
That's a good idea.
That's another one of the options.
Have we done this on any other places where we had loops? We don't have.
But we have actually in, I think in the encoder space, already in framework APIs, we have existing APIs that basically do things in chunks, and then you call final This one is slightly different because you don't have to call final on the at least decoder side.
But what do we have on the other CoreFX lab encoder?
Oh, okay.
We have normal loops, so we don't have chunk non-chunk. Right?
Yeah, because we don't have a final step, like, you know, or do we? Base 64. What did we decide for base 64?
There is an is final Boolean parameter you pass to your buffer.
Oh, okay. But you see, this one, like the decompress, doesn't have the concept of final. It knows when it's done, so there's no reason to do it.
I mean, the compress does though. Like,
Yeah.
another one of the options is instead of having compress and compress final, you can just have compressed and then have an is final boolean.
Mm-hmm.
Yeah.
The behavior might be a little bit interesting to work around just because this is a stateful type instead of a stateless type. Because could you run into situations where the compress or decompress routine, because it's trying to do an underlying buffer flush, doesn't actually consume any source, but still writes to the output buffer?
Yeah.
Stuff like that.
Yeah, but I think, you know, it may be easier to write software if you have just one method, because you have a loop, and basically you just call compress, and in the last parameter you pass in whether remaining and whatever you're passing is the same. If they are the same, it's the final block.
And then you have to keep calling that in a loop with is final equals true.
Otherwise, you have to have an if statement and then call two different methods and two different, you know, pass two different sets of parameters. It's like the loop gets more complicated.
The implementation I have now is basically what you just said. Like, I just have one method, and you just pass parameters for whether or not you want to flush or finalize or just compress.
So maybe that's what we should do. And it would be similar to the base 64 decoder.
Yeah, that's what I'm thinking. I mean, like, if you look, I mean, it's not really going to be super similar just from a naming standpoint.
We wouldn't have a flush then, though, if we did just an is final boolean.
I know.
So we would lose that functionality.
That's what's making me nervous.
Unless we had two booleans, but then that's
What would we lose?
flush capability. So like not finalization, but intermediate flushing.
Yeah.
Oh, then we should.
It's really useful for real-time streaming.
Well, we should just add a method called flash.
Does it take input?
No, it flashes whatever it has.
And you keep calling that in a loop until the buffer's flushed?
No.
Why?
You call it when you need.
You just
You call it once.
You call it once, but how big of a buffer do you provide it?
You don't provide a buffer. It flashes whatever it has inside store.
To where? You have to give
You have to have a destination buffer for a flush.
Well, in this case, you do because you don't have state.
Yeah.
Well, what, we could just direct real fast. What would the flush API look like? I mean, we have...
I mean, it's the same as what we have, right? It'd be compressed final, except it would be called flush.
Oh, okay. So this is the thing that I also kind of commented on. I'm not sure how to design it. So operation status returns destination too small.
Mm-hmm. Or needs more input.
Why can't you keep calling compress and, you know, keep passing more destination instead of having flash?
You mean without input?
Yeah. It's basically equivalent to your flash that just takes the destination.
Really?
It's
Because
equivalent to this compress final.
the underlying implementation could just choose to keep buffering data until it has a full block to compress.
Yeah, that's the problem. You need to actually tell it to flush if you want it to finish that block. Because it's not an issue of not having enough destination data for why it doesn't flush. It just is waiting until it has the optimal amount of input.
Because it wants to compress as much data in a single block as it can.
Yeah.
Because that's, like you said, the most optimal.
And logically, like, compression works, you have the sliding window, right?
Yes.
Yeah.
And then at some point the window is full and then the compression magic happens, right?
Yep.
But when you're at the last block, well, there's no more data, so the window never gets full. So you have to tell the system somehow, I'm done, please write it out.
Correct.
Yeah.
So that's the final.
So normally that's what this final is for, but you've disallowed intermediate flushing now.
Okay, and intermediate flashing, so maybe what I'm getting confused is, it seems like there are two different reasons to do intermediate flashing. One is, for some reason I want the data to start flowing. And then the second one is, I have data in the input buffer, but there was no room in the output buffer.
No, it's really just the first, I think, that would be
It's only the first one.
scenario.
It's just if you have that intermediate data that you want to then pass to a decoder somewhere.
Because as you mentioned earlier, when the application's in a steady state, it's just going to be calling this method in a loop, right?
Mhm.
It's not really going to care how much data is in the input or the output. It's just going to do some, offset fix up and then just while true, while true, while true. But yeah, as soon as you run into a situation where I'm working on a real-time chat application, I need this data to get to the caller or to the recipient now. At that point, you need this API.
But I'm still not quite sure, how does Brotli work under the cover? So let's say you flush your current window.
Mm-hmm.
Does that give the receiver of that pipe enough information to decompress everything up until that point?
The only problem with that is that it depends on the actual implementation for whether it wants to then parse that normally or if it wants to treat it as the end and throw an exception if it doesn't have an end byte.
Right.
That strikes me as very odd because normally deflate stream doesn't have this problem.
Deflate stream does not have that problem. Deflate doesn't have that problem in general.
So, but if
It's
you're
specific
using
to Brotli.
But if you're using a deflate decoder to decompress a Brotli stream, I thought we were saying that
That was Zopfli, not Brotli. That was the precursor to Brotli.
Got it.
Google abandoned.
Okay.
So Brotli and deflate are not interchangeable.
Okay.
Okay, so
And there aren't very many Brotli decoders. There's just the ones in browsers pretty much.
so how do you flash today? Compress final is what you're calling flash?
Yes. It's both flush and finalized, depending on the state. Depending on the is final or is finished.
So we don't have a way to flash intermediate data.
No, that is intermediate.
You said it's final.
Passing final true.
It's like,
False. Compress final is finished false. It's not a good name.
There's a parameter to compress final? Oh.
It's in,
Can you
it's in the
expand?
option section
So
down
we
below.
can see the whole API?
It doesn't have the source. That's compress except the source.
It have the other ones.
I just copied it literally from the GitHub. Like that was the one that I copied.
Yeah, it's one of the design questions for whether we want to allow intermediate flushing. Yeah, flush versus finalized.
Oh, I see. So here's the parameter, is finished.
Yeah.
So basically, is finished is to control between intermediate flashing and I'm done.
Correct.
Okay, so could we have an API that basically just has a compress method and flash?
Yes.
What would the signature of flush be?
Where would you get finalized though?
I think you're just advocating renaming compress final.
Basically, no. So I would add a parameter to compress with a boolean
Interesting.
is final. So it's exactly like the base 64 encoder API.
So that means most maintenance scenarios would only call this
use
API.
flush.
Exactly.
Flush is like a special scenario.
And you have some special scenario, we have a method flash, and it basically has. But like, what are the parameters to flash? Because it's
It would just be destination and then bytes written.
just destination and bytes.
Is it like same as
You cannot
compressed
add any
file?
more data when you flash.
Well, possibly also.
could. And that's, I think, the one after that, allow input to flush finalize. But, I mean, the underlying API allows you to give input to a flush or a finalize. It's just, does that make sense from an API standpoint for us?
How do you know when the flush is done writing to the destination buffer? Flush would return operation status.
Yep.
You call it in a loop.
Yep.
That seems strange to me.
It is a little strange. I mean, that would also happen like if you give it too small of a destination buffer. It'll return needs more output or whatever.
Needs more output. Like for regular compress scenarios, I can kind of get that, but for a stateful API, especially like a spongy API like this, I would expect certain values of operation status never to appear ever anywhere.
Needs more input. Needs more input will never appear on a flush.
I would expect that never to appear anywhere.
So if you don't have enough data in the window to flash, it would be just bytes written 0. Is that what it?
I mean, if it for some reason can't write a whole block, then yeah, it'll be 0.
So there is a scenario for operation status, not enough data,
Not enough input?
not enough input.
Flush?
Yes.
That
Definition
doesn't
of
make
flush
sense.
is like just cut it off, right?
Yeah, the definition of flush is whatever you have has to go out right now.
Yeah. But if you don't have
think
enough,
flush would return
basically.
needs more input because in most cases, all the cases I've ever seen, it will flush and give you an entire block regardless of how many bytes it has, unless it has 0 bytes.
At which point it's a no-op.
Yeah,
So, yeah.
but it'll return needs more input.
So if it has 1 byte, it can
Because
actually...
what else would it return, right?
Done.
There isn't a done, there's a success.
Well, success. A zero-link success. Seriously, like there was no input, so a successful flush was.
We could change that, but the way it is now, it will return needs more input.
So if you have 1 byte in a buffer...
There's flush, which is basically the current definition of the framework is you have like you don't have to pass in the buffers, right? Like streams hold onto their own buffers.
Mm-hmm.
Flush just means whatever you hold on to your own buffer, just write it to the underlying thing, right?
Yeah.
That's one definition. The other definition is finish the current window so that the receiver of the thing has enough data to decode to basically start decoding.
Well, it's
Which is a very different thing, I think,
Yeah.
from that point of view, right? Because flush in your world here basically means write like finish the current window.
Yes.
So that when you have somebody reading, they can read the entire window and not have to wait until the middle to get more data, right?
Yeah.
In which case, I would argue when you talk about the flushing of the window, not enough data makes complete sense because you have to have enough data to finish the window. Versus in the normal flush state, like it doesn't make any sense because all you're saying is that whatever you're holding onto yourself, just write it to an underlying thing, and that makes no statement about whether that's enough or not. It just means stop holding on to data, which kind of means to I think flush may not be the best term for the API because I think it's.
I don't even fully understand when would you want to call it. Like you
called
said,
flush.
Yeah.
So you're writing a chat application, a web-based chat application, right? Like maybe you're working with like customer support on a website somewhere. Now you as a chat representative like ask a question to the user on the other side. That question, like the ASCII text, ends up through the Brotli encoder. Like the ASCII text is only going to be this big, right? The buffer's huge.
Sure.
So you hit enter. When does the question that you typed actually make its way over to the customer to see?
when you say it's final, because it's final. You just
So
say...
the stream itself is still open.
Sure, this API has nothing to do with streams.
No. I mean, like the underlying network stream is still open as far as the browser is
This
concerned.
API is not tied to streams. It doesn't take streams, doesn't hold streams. So I don't
What
know.
he's saying is like imagine I don't know what the Brotli encoding looks like, right? But presumably you have a header and then content, right?
Yes.
So when you now read a stream, do you expect to see another header with another set of content, or do you think you only say your header once and then continue this content?
Because what I'm concerned about is you mentioned that at the end of the final encoded block there's a finished file.
There is.
Right.
Is that basically like an end of file marker?
It's not really end of file, but essentially it says that this is the last block you're going to get in this set of data.
But if you have a decoder, could the decoder decode more data after that, or basically
That depends on the decoder. Ours can't and Google's can't. So I would say no,
Cannot.
cannot.
So I guess what I'm thinking, my mental model is if I'm using a web browser that sees one of these bytes come in at the end of a question, now the browser says session disconnected.
It shouldn't disconnect. It should just reopen another instance of the Brotli decoder then, if it's expecting more input data.
How does it know to expect more input data? It just received a marker saying.
Presumably from the network stream, right? If it receives more bytes from the network.
These APIs are like very low level and kind of almost stateless, if not for the fact that they have some like Brotli specific state. They cannot be participating in the networking protocol.
No, but I think
when stuff starts and when it ends.
I think what I said earlier, I think maybe the better model. So what you have here is basically the situation where you have you basically you compress data, right? Now the thing is, let's talk about how the form of the data looks like. Do you have a header and then like chunks of encoded data?
You got blocks, yes.
Yes. And there's a header at the very beginning, or is like every chunk the same?
There's a header at the very beginning, and then blocks, which each have their own header. And at the end of the final block, you've got a couple of bytes that say this is your last block.
Yes. So now this begs the question of like, okay, given this information, where you have like header and then some amount of chunks. Write that. Like, should this API allow you to basically do a thing where you are able to, have chunks in the middle where you're saying, the chunk is not complete for the window size, but I write it anyway so that at a concurrent decoder never has to deal with another set of headers.
Decoder never has. I don't understand.
So that the current decoder doesn't have to finish essentially and then start over again with a first header. I don't think the cost for that would be high though, because the header's not big.
No, but this goes back to the interaction you guys just had, right? I mean, because if you say you have to do that, then no one imposes limits on the consuming side of like, oh, do you have to reinstantiate this thing? Or do you know when to reinstantiate this thing? Versus if you basically just have two open connections, and one of them is just putting data in, the other one is just pulling data out, then the only logic you need is to say, finish the current window. Yeah. Because the consumer can just decode that one chunk, and everything else just works out. And these guys that never have to resume. Right? They have this illusion, if you will, of one contiguous stream of compressed data.
Yeah.
And the stream itself just may stop at some point because it's waiting for somebody to type a chat message, but then as soon as this chat message is over, well, you decompress that chunk over. Right?
But I still, maybe I don't understand one thing. So there's this native structure that you hold to. When do you write to the destination? Or this destination buffer?
For
you write for encoder.
So for the encoder, what it'll do is it'll get pointers for both of them, or whatever spans you pass in, and then it'll pass both of those to the underlying API. The underlying API will take the information from the source pointer, do its internal stuff, and then put it in the destination pointer for you.
But does it do it eagerly?
Yeah.
Then what does Flash do in addition to what it already is happening?
Well, what do you mean by eagerly?
Meaning, like, if I want to Flash, I just keep passing destinations and it's writing as I go.
If you give it, say, 10 bytes in source, but it needs, say, 40 to complete a block, and if you keep giving it destination to compress, it's not going to do anything with that 10 bytes.
Okay, so now maybe I understand. So Flash does not mean write, if you have enough data for a full block, write it. It means
write the block no matter what.
Don't wait for more data.
Yep.
And it's different from a final block because it doesn't put the final thingies at the end.
Yep.
I see. I understand now. Yeah, that's a bit strange.
Maybe we just do compress for now, and then if people ask for flush, we add flush. See if we're missing anything. It's easier to put things in later than take them out.
How would you put it on stream though? Just no off it at the moment?
For flush?
Or Brotli stream, yeah.
We can still do flush the way we have it now.
But you just said that the underlying encoder wouldn't support it. The API wouldn't exist.
The Brotli encoder, Brotli decoder wouldn't. But we could just hit the native ones. Right now, what we have is Brotli stream is built on top of Brotli encoder, Brotli decoder, the struct ones. It does not have to be. There's no particular reason why it should be.
Well, it generally should be just for ease of maintenance.
It is more easy to maintenance, yeah.
So, Ian, I guess the key point is, like, is this thing existent or is this not existent?
Pretty much, yeah, that's the question.
Because then the question is basically just you need to differentiate where you want to just finish this one versus also writing this one.
Personally, I'm in the camp that I think we should do the finished block at the end of every set of data. So we don't have a flush, we just have a finish. Because I was looking around, some of the decoders are always going to expect the EOF equivalent. And they don't like it when you don't give it the EOF. So
they don't like it when you don't have it at all? Or so basically, would it be legal to say, you have this, right, then you send this, and then you send another chunk, n+1 essentially here. Would that be legal then? Or
no,
is that the expectation? No, you set an EOF, so you're done. So you know
that is the expectation.
All over again with header.
It's sort of the corollary to the encoding flushing, right?
Right.
So the decompressor will have its internal buffer, and it takes chunks, and it's not going to actually flush that data to the underlying destination until it sees that EOF.
So that basically means that the question for us is, do we care about being able to, you have enough, let's say the buffer size or the window size is 2K.
Sure.
But you want to say, I only have 80 characters, I want to write a chunk, but I don't want to end to transmission yet.
Yeah.
Well, except...
if you care about this or not, then we need to have an API for that somehow.
But then the question is, on the other side of things, the decoder, does it see that chunk and do the whole thing, or what if it has a bigger buffer? What if its buffer allows 2 chunks? Does it wait for to fill the buffer? Or does it just get 1 chunk, your halfway finished chunk, and then...
I don't know what the chunk looks like, but I assume they have like some sort of micro header that says, I have... I don't know how you decode that, but basically I guess from the decoder standpoint, they should be able to decode the data that is entirely in this chunk. And then, if if it's like a checked client, then the expectation is that this is just text, so like you know that this is a unit of work. If it's like a JSON document and then you're like in the middle of a JSON document, then whoever basically decodes that Brotli message will not be able to do anything meaningful with it because it's still waiting for the rest of the JSON to arrive.
Yeah.
But so like that's more like then you're talking about the data itself, but the underlying data itself is like stream enabled, if you will, right? But this is just talking about whether the compression itself can be stream enabled, right? Which is, to me, I mean, either we care or we don't. I mean, I don't know whether Brotli is used in such a scenario as Levi was saying. I mean, if it is, then maybe we should have that. If it's not, then methods compress and compress final, or like sorry, have a similar API with the basic C4 style boolean at the end. In which case, well, you call this guy, you pass in true, and then if you want to do it again, well, then you start all over again.
So what's the cost of creating this structure? Like all the native machinery. Like, does it make sense to reuse? Let's say you have the scenario that Levi was talking about, like a chat client.
Sure.
Right.
And you basically, we don't provide Flash, so you have to like say, I'm done.
Yeah.
Today, if after you say I'm done,
Yes, that's it.
can we make? Is it expensive to recreate this?
I'd have to
structure?
run actual perf tests to give you a good answer.
Because if it's expensive, maybe we need an API to basically be able to say, yeah, I just called done. Now
Isn't the performance of that, because I'm sure we can always improve that. My concern was just I don't know if the browser will understand it correctly because I don't have enough data, and I'm reading through the spec, and the spec doesn't really talk about this.
But what I was saying, and maybe I'm wrong by the way, what I was saying, it has nothing to do with browser. This API has no tie to browsers, to streams. It doesn't do actual flashing for you. It just moves data from one span to another. It's up to the consumer of the API to do the right thing for the browser, from the browser's perspective.
That's his worry, though, is that maybe the browser doesn't expect this EOF method. Maybe it sees an EOF and says everything's done now.
Yeah.
Right.
And we want to be conformative to as many implementations as we can for the decoder.
Well, the one and only scenario for it right now is use inside of a web browser.
Yeah, that's the only place you can find a Brotli decoder is web browsers.
So basically, it's all about differentiating between finishing the chunk and writing EOF, and finishing the chunk and not writing EOF, right? And so, like, the question is, what do consumers do when they see an EOF? And like, that may or may not what we want.
So another thing we could do is kind of reverse it. I'm now brainstorming because there are some issues I just noticed, but we could have, final means just flash all the data, and then we could have write EOF method.
So basically, everybody has to call write EOF.
Is EOF always the same? Is it like a constant payload, or it varies?
Well, it's not exactly an EOF so much as it is you're telling the underlying native implementation to finish the block with those EOF bytes. So I mean, you wouldn't want to do like a flush and then another EOF. You don't want to finish this block and then put another block there with just an EOF in it.
Why?
So you write two blocks instead of just one.
Yeah.
Because what I'm saying is, if it's a constant, we could have, final. So you're now done with the native implementation, and now this API just has a.
I think what Ian just said is like the chunk itself has some metadata in it that says this is the last chunk.
Yes.
So there's no EOF marker. It's just that the chunk itself is written differently. So if you make it two things, you end up writing an empty chunk that just said I'm the last.
I see.
So you just write more data.
So what happens if you flash, and then you separately want to write EOF, but now you don't have any input data?
You have to write a whole empty block with just EOF in it.
Is our API, will our API actually do it?
Yeah.
It looks like per the spec there is a shortcut, like something that you can just stick straight in the header of the last block that says, I'm an empty block, oh, and by the way, I'm also EOF.
Yep, that's it.
I see.
So that's the reason why you can't do the whole full flush and
we could literally, the most straightforward translation, I'm not sure whether we like it, but the most straightforward thing I can think of, like we just have two bools, which is basically finish chunk and finish, I don't know, is final block or something, right?
So you're saying we have an enum.
Yeah, because you don't want to, it's not two independent modes. It's basically will be an enum, right? It's either just like normal, which basically just fill up the chunk. The second one is finish the chunk, and the last one is finish chunk, and this is final.
So internally it uses an enum.
Yeah.
It takes an enum that has either finalize, flush, compress, or metadata block, I think it is. And metadata block we don't care about. But the other three we would care about.
Yeah. See, the problem that I have with these kind of things, I mean, I've not really made up my mind whether I think it's a leaky abstraction or it's just part of the ceremony that you cannot really abstract away from the caller. But it seems a little bit like similar to base64, we had the same discussion, right? Like, is this final block thing something where we leak the way the format looks like? But
I don't really think we should use the enum. I think that's probably one of the worst routes. I would much rather just have compressed and then compress final with the bool for flush or don't flush. Or flush or finish.
Well, but then the question is, what do you expect? Like, do you think it's easier for the caller to reason about when they call which API rather than when they, because I mean, like, you have two methods and then you have to know which one to call one, right? But if it's just an enum, it's clear you call the same thing.
Yeah.
And then ideally the names just get longer or something, so and then there's some default and it's fine. But yeah, I don't know.
So I would almost say that, like, maybe I'm wrong, but the flash is kind of rare, correct? Like,
It should
the
be.
scenarios for
Intermediary thing without the
So,
final block.
yeah. So I would say, like, the first compress method should be the regular base64 like pattern.
Means SignalR will not work if you use Brotli compression.
Why would it not work?
SignalR, when you're using server-side events, depends on flush existing.
Yeah, but so the first method is, it doesn't flash, it just, I'm final. And then we just have a flash method for the specific case, specific scenario. And the flash method is, I kind of also find it strange that it takes a destination buffer only. You kind of have to,
For flush?
yeah.
I mean, that's pretty similar to the stream interface, right? Yes.
Not really, because stream is always guaranteed to consume all of its data, whereas these encoders are not, and that actually makes flush very hard to use. Because say that you call compress in a loop, and compress returns needs more input because it didn't actually consume all of the input.
Yeah.
Do you, and now you want to do a flush, do you call compress again? Is it guaranteed not to return needs more input? Like, what happens if compress returns needs more input, but you've given it all of the input you want to give it before a flush?
Yeah.
You're dead in the water at this point.
So why exactly are you dead in the water? Why can you? Is this under the impression that you don't have a flush then?
I'm saying if the scenario is that I've put 1 byte into the buffer and I want to flush that out to the network.
Yeah.
If I call compress and pass 1 byte, is that for the source? Is that guaranteed not to return needs more data? So if it returns
Return needs more input.
if it returns needs more data, what am I expected to do as a caller?
Why does compress return need more data ever?
Yeah, like in
I may have 0 bytes or 1 or 2 or 3 or 5. There's no like a minimum size of the input to compress. Do you know?
Yeah. So, I mean, it doesn't have to return needs more input.
Yeah.
We could just have it return success, but
When does it
then those
return?
bytes wouldn't be written to the underlying or to the destination span.
yeah.
Are you
it's
saying
finished
today
or flushed.
you return needs more data for the case where you're basically holding the output
Yeah.
to get more? Yeah, I don't think that's what needs more data should be used for. I think the intention for needs more data was the format is invalid if you don't pass me more data.
Yeah, that is.
So
not,
there
that
are
is
some
not the case.
formats, like base64,
Mhm.
depending on whether you encoding or decoding, you need to have the chunk size is 4 or 3.
Mhm.
You cannot pass 1 and say that you're done.
So that would give you needs more input.
Exactly.
Okay, so yeah, that's a pretty different behavior than from what the Brotli does.
Okay.
So I guess what you're saying is that you are returning more data when the window isn't full yet, right? Is that fair?
Yeah, that's the idea.
And then you basically. So what happens when I basically pass in just enough data that finishes the window, but not more? Then you return just success, I suppose. What happens if I give you more than what's remaining in the window?
It's more data.
Then you basically fill up the current window, write that out, and take the remainder and put it in the beginning of the new window and return me not enough data, I suppose.
Yeah, that's the idea.
So maybe we need to add one more value to the enum. A value called something like buffered. So people are not surprised that they call the API, it returned success, but nothing was written. That is kind of surprising.
So in your case, isn't it fair to say that needs more data is almost like throw argument exception, like the method cannot work?
No. In which case? In his?
No, in your case, like in his case, you could argue that there's nothing the caller would have to do regardless. It just throws in data, and at some point you just write it out, and
Buffering.
You don't care whether they're buffered or not. You just want.
No.
to
So.
But in your case, you're saying I need 1, 2, or 3 characters. I cannot take 4. I cannot take 1.
What you gave me so far is invalid.
The
Basically.
reason it's not an exception is, so imagine that you're like base 64 encoding,
Right.
and you encoded this chunk and this 1 byte here.
Yes.
Let's say 32 is a space.
Right.
Well, you don't want to throw because there is additional buffer here in the pipeline. So if you pass just this chunk, it cannot do its work. It says need more data. What you do is you take the next segment from the pipeline, you stitch them, and now you pass the the 4 bytes.
Yeah, I guess what
What if the end of the next buffer is again 32? So where are you going to get there?
What do you mean?
Oh, you stitch together the next buffer,
Yes.
but at the end of it's 32 again because it's it continues.
Well, the base 64 encoding API, it will not say needs more data, it didn't do anything. It will actually start encoding as much as it can.
Oh, I
and
see.
then say,
Also, it's for the
I couldn't-
encoder, not for the decoder.
I couldn't.
Okay.
I couldn't encode everything that you passed me. I encoded as much as I could, but I need more data to encode few more at the tail.
Yeah. Need more data, it doesn't mean I consume nothing. It just means I couldn't consume everything.
Yeah.
It might mean I consume nothing in some cases, but the intent is that.
So in this case, in the Brotli case, it consumes it all. It just doesn't write it all.
Yeah.
So
If it consumes it all, then it should return success.
So I think in general, like
Okay.
I think it's
we
a
can
new
certainly do that.
enum value. It's basically like buffered. I consumed all the data.
Yeah.
I didn't write it not because the output is not large enough. I didn't write it because I buffered.
And
what do you do
now-
with that information?
there's also a question there: how do you determine whether it's buffered or it's been written? Because what if it's only partly written?
Exactly. What is
Is that
both?
success or
Because
is
you
that
finished
buffer?
one chunk and you started the next one. What are you going to return?
It's buffer still.
That's what a
because
has
you're
data
still
property is
not-
for on the encoder.
If you basically, so most of these APIs, there is input and output,
Yeah.
and it either gets moved from one to the other or it doesn't. Of these specials, it basically
Buffers, shit, yeah.
partially moves the data from input to output, but some of the input is sourced for later.
So wait, you're always going to have buffered then, unless you have the exact size of that block that you need. So what's the point in having it at all?
Well, so it's an enum. We need to return a value.
Yeah, sure.
The one that you said success, I think we call it done, not success. Or maybe it was renamed, but it
I'm
was
not
called
sure.
done, meaning
Brotli
I'm
results
done
for
with
operation status is success versus done. I'm not sure
Yeah,
which
yeah.
which.
So this one it's not done, correct?
No.
It's not done.
No, it's not.
Well, it doesn't need more input.
No.
And it doesn't need more output.
It needs you to.
And
make
it's
it
not
work.
an invalid data. So like we need a new.
Well, what this tells me is enum for a stateful API.
We could just have it not
Well,
return
but
operation
then we-
status.
But then we have additional enum. Yeah.
That seems
Yeah.
worse.
Well, but then keep in mind what you just proposed is that we add buffered as an enum value to that enum. Now, what happens if a stateless API returns buffered?
So I think
For happen, granted.
should never happen. But I think
Callers don't have to be defensive against that.
Well, mean, I think in general these APIs need documentation because I don't think they're like. I think if you use the API for the very first time, I don't think any of these people will be successful.
Yeah.
Like, I mean, just looking at the IntelliSense, I don't think you can be.
Well,
So here's another option: is not have operation status for compress at all, and just use a bool. Since we only have two operation statuses, then right? We have need more output, or we've compressed some stuff, and we may or may not need more input,
Why wouldn't it just return void?
or whether or not you need more output.
No, if compress returned void, and you had another method which was write the compressed data to this destination buffer, that method.
It's possible, yeah.
But
There's even an API for that in the native one.
But compress at that point would just be guaranteed to consume all of its source and do something with it.
well, so what happens if I pass an enormous buffer as a source and a very small as the destination? Is the Brotli internal data structure, can it store very large input buffer?
Depends on how very large.
Well, it's span, so it cannot. Oh,
It means the
they will
internal,
copy it?
I passed a 2 gigs. I passed a 2 gig source span and 1 byte output.
Yeah.
What happens?
Destination.
And vice versa.
That's what the purpose of the bytes consumed is.
Yes.
It'll only take what it needs to finish that block, and then if it doesn't have more space, it'll stop. And then it'll say bytes written is your 1 byte compressed, and the bytes consumed is 1 byte.
Right, but
And
then
what's the operation status that you return?
Oh, that
we'll put destination too small, right?
probably needs more output.
It's more output, yeah.
So
Destination too small. Yeah.
Okay, then therefore the method cannot be void.
Yes.
You need to tell the caller, like, you need to pass me more output.
Exactly.
bars.
So it cannot be void.
But it could be a bool.
Could be, but then integrating the pattern, right?
Yeah. It's just a question of whether the operation status pattern makes sense.
I mean, so we have another option. We could just rename done to something like no action needed or something, right? Because basically, done for the caller is irrelevant. It
But
doesn't
buffered is not, action is needed. So you started to talk about what would the algorithm do. If it's buffered, you cannot now stop. It's not the same as done. You basically, there's some data that was yet not flashed. You have to somehow cause it.
but that is controlled by you, right? Because basically, if you pass in true for the final block, the API should never return buffer. It should return whatever the equivalent of done is, right? Because you said this is the final one.
Yeah.
Intermediary calls where you said it's not the final block. You don't care whether it's buffered or not because you're not done yet anyway, right?
Yeah.
So for you, there's no action needed for buffered. I would assert.
Probably right.
In which case, it's just non-event, right? You just say, well, destination too small, the caller has to do something.
Well, it's unfortunate that now it depends on the parameter, as you said. If it's final, yes, I agree with you.
Well, the parameter, like, it's more like, saying like, hey, I'm, this is the final, so you should finish everything, right? You're telling it explicitly, basically flushing.
That's how base 64 works today. It returns a different operation status based on the value of his final.
Yeah. Because it either needs more data or it's...
Or it's invalid.
Yeah.
Mm-hmm.
The only difference is that in this case, it's never invalid. We're just waiting for more stuff to happen.
Fine. I think maybe we could return a boolean, but and now the question is it worth it?
Well, I would not do a boolean. I would still return operation status. I would just maybe consider renaming done to something that implies less of a this is the end.
Well, what was wrong with success?
I like success.
Yeah.
I think success makes sense.
You said that was the original name?
No.
So
No. I
there's
don't
a
think.
Brotli result native enum that has either success or done. I don't know which one. I don't know whether it's success or done, but then operation status has the other one. So
I think in operation status we didn't call it success because it implies that the others are not success. They are.
I see.
Done means, there was
The operation.
there was a sequence of things you had to call, and now it's over.
Or something.
Yeah.
sure, yeah.
But you could argue that
Yeah.
done will never work for anything that's buffered.
There's also the possibility we might not be able to use operation status. So that's
Yeah, that's the
probably
thing,
less important.
Yeah, like I would like to avoid that because to me, one of the values that this API gives you is that let's say we have like 20 enum members at some point. Well, then the enum is horrible. But if you end up with like 4 states, and you only have to learn about what these 4 states are, and then there's just some cases where one of the states are unreachable, I think that's much easier to understand from the caller side than to understand each and every like kind of way you can shuffle bytes from one to the other, and then this guy returns bool to indicate that it's half of it, the other guy returns false to indicate that the destination was too small, and then it gets really more complicated. Because then basically you have to deduce the error states based on the relationship of the out variables, which is what we had originally, and like that.
Yeah, that's another thing you could do.
Crazy math that never works.
I'd like to avoid that.
So we're at 309 now. I think we should push through because we are close. But
I mean, I think doing the compress with is final and then having a separate flush is probably the way to go. And before we decide on flush, I want to do some more research on what the browsers do when they hit EOF, because it's possible that they treat this as equivalent to
kill it.
This, or is it possible that they decide that the stream is done, everything's done, let's exit. So I want to find that out first before we decide if flush is necessary. But I think having compress with is final is good either way.
Okay. Yeah. So now I agree, but we saying that for now we are returning operation status still from the API from compress.
Okay.
What about flash? No.
I feel like it should probably have one. Because you still have the success state and you have the needs more output data state. Or needs more
destination too small.
Destination too small. So there are still at least 2 states. And possibly error. So I think it should still have operation status.
Well, error, if there's an error.
Like you can encode anything, right? So input data will not have error.
Out of memory.
Or if
catastrophic, like you're not doing it explicitly.
Yeah.
Another one would be if you already finalized it and then you tried to flush. But again, that's something we can change.
I see.
We can make that return success, for example.
Exception.
That's an exception.
That's an exception. That's exceptional case you misuse the APIs.
Yeah.
Okay, so for the
so at least 2 then.
So for flash 2 and for compress, how many states do we have? You need to read the
how many states or how many possible return values of operation status?
possible return values.
So for compress, it's error. It's then success.
Error because of what?
Too small.
Error is an exception, correct?
Yes.
Error as an exception. Destination too small.
Yeah. Because you get the 2 gigabytes and you have only 1 byte in the output. What do? You ask for more.
Whatever buffered would be, or success, either one. But then in this case,
I basically consumed and I buffered. I wrote whatever I was about. I had to write.
Yeah.
But
you gave me some stuff and I used it. You're good.
There's no invalid data. I see.
Well, the second that you mentioned might be that you didn't write anything, but you just you have stuff buffered. If you in the meantime were able, successfully wrote something out, that's combination to that.
So I think that's good.
So it seems like maybe it's an overkill, but if we return operation status from both of them, it's kind of there's a bit of complexity because there are values that are not ever returned,
yes,
but also there's simplicity because they all kind of work the same. You learn, as Imo said, you learn the 4 values, and
from that perspective, I agree. However, it's gonna come. I've lived through it myself so many times that you look, hey, did return some what the fuck? How many values do I have to kind of watch over, right? What do I have to protect myself? What do I do if it's none of them? Okay, throw some exception. That's basically that code. Yeah,
I think we should have the
not going to
operation
be
status.
super pleasant as well.
Or corollary.
Just want to make sure that it's for users.
I agree that there is the trade-off. It's just the alternative is
Booleans are bad. Yeah,
we can make the second one Boolean.
When you say the second one, you talk about compress final?
The flash.
Oh,
correct. Boolean basically means I'm done.
Succeeded or not, right?
Sure. Yeah.
So what I'm a little bit confused by is what are we designing right now? So basically what we just said is we take our compress API and we add the isFinal block here, right?
Yep, I think that's good.
And we should default it to true because that's what base64 did. I think it's weird, but I don't know.
Really? For a stated one? That seems wrong.
Let's do the same thing that base 64 does.
Yeah, true.
Is it true?
Yeah.
It violates our guidelines. But maybe it's fine.
Why?
No, that's
Our
because
guidelines say that defaults of properties should be what the default of the type is. So the default of Boolean is false.
That's an odd.
otherwise it is not final block true. It's what the fuck?
Anyway, the Chrome browser, once it sees the last metadata marker, will destroy the decoder.
Yes. The question is whether it starts a new decoder if there's more information after that in the stream.
Pick it up.
Okay, the next half.
It'll have to destroy it either way.
Having said that, the
That's-
guideline
that's-
is kind of silly.
that
But
begs the question of what
I
the
think
cost
we
is.
basically should do what base 64 does.
My other question is, why should this be defaulted at all? Because you have a loop, right?
Yeah.
You're not calling two. If you make two different calls, then you're holding it wrong. I would argue. You already have to track in an expression somewhere that's the last block or not.
I think
you always
I think basically, let's say you just want to call the method and be done with it.
Well, then you would
So-
use the static one, right?
Exactly.
You will use
You'd
what?
use compress fully or try compress it.
There's a compress fully. I don't see it.
Yes, it's right up under compress. We have a try decompress and try compress or compress fully or compress data or compress
Where
whatever.
is it?
These guys here.
131?
Oh,
Oh, sorry.
compress.
36, 37.
Oh, compress data.
Yeah, naming is a little bit.
Yeah, naming's not great.
Okay.
So if we only want to do it once, then we just do the static ones, compress data.
I see. Try compress.
Yeah, sure.
So just to be consistent. So that would make sense to me.
So then in that case, I think that,
You lost me. What's doing that once or what the heck?
yeah, so try compress is a static thing whereby
Oh.
you don't have to make a Brotli encoder. You just
Okay.
give it source, you give it destination, and you're done.
And either it works or not. Okay, fair
Yep.
enough. I see.
Return a bool if it succeeds,
I
and
missed
false
the
it doesn't.
static part, yeah.
So then, if we have try compress, then I think is final block needs to default to false, because you're going to use compress with is final block whenever you have, you don't know that you'll be able to finish in one iteration. You're gonna loop.
Yeah.
So is final block needs to be consistent across all APIs that we ship. I think it would be very, very bad if the default is different depending on API. Everybody would get confused because
But that's what I'm saying. To me, you only have two options. Either you, I think it's okay to say this one is not defaulted because we can
Correct.
have a consistent default.
yes.
But I think it's okay if other things are defaulting. But I think everybody
Sure.
would use the default.
I was just saying we cannot have between base
Yeah.
64 and this one different
Yes,
default
I
for the
agree.
same parameter.
So
because
I think
you would
but that's what I'm saying. To me, the defaulting this makes no sense to begin with.
I agree.
And then if we have to default it, I think the only way that would be sensible is
Why does it make sense for
Is
base
not final block.
Why does it make sense for base 64?
because base 64 only has a static, right? It's not the whole API is basically not.
It doesn't have this state. Yeah.
Okay,
So basically, you're combining these two guys here, right?
makes sense.
Effectively.
So yeah, let's just leave his final block as non-defaulted.
So okay, yeah.
So they have to supply it.
I think we also need to rename the compress final.
Well,
So basically does not it doesn't put
So
the final
so
marker.
from the discussion earlier, compress final is now flush.
Yes.
So
if
that,
we ever need it.
If we decide that we need it, depending on what the browsers do. So that one's tentative.
So
so why does this have to take any data? Why would it not be just?
It doesn't take data. It just has destination. Because otherwise, if you flush data, where does it go?
Oh, I see what you're saying. And then, okay, never mind. Yeah, that makes sense.
Technically, it could take source, but I don't think we should do that pattern.
So should we have its final block in Flash?
I don't think so. I think flush should only be for the case we have intermediate data. Otherwise, you have two APIs then that do the same thing.
You
So
can
basically-
flush and then you can send 0 bytes and call it with is final block true.
I see.
Yep.
Okay.
And then my last question is why are these methods not properties? Because it seems counterintuitive.
They can be methods, they can be properties, or they can be constructor variables.
You can change these while everything
You
is...
cannot. So that's the argument for why they should be for constructor variables, which is what Christoph wants to do.
Yeah, that's what I would do. Like that. I mean,
The reason I have them like that instead of being constructor variables is because it's a struct. So I kind of wanted to have the default struct declaration and .set quality .window, but
You can still have default.
Really?
Yeah.
You just do the bracketed thing.
You just on structs cannot have just parameterized constructor,
Yes.
but you can have a default one and parameterized.
Yeah. I have that in the issue too. So we would just have a default, and then we have one that takes a quality and a window.
It's just the default when you like create the struct. Do you do anything in the constructor? Like
No, I don't.
you just store basically whatever will pass you. That's all you do.
Yeah.
Everything is lazy.
Yep.
The only problem is
We don't run constructors when you create. We don't run the default constructor when you create like an array of structs.
we don't run it at all.
That's the problem.
That should be
You
fine,
physically
right?
cannot declare
Yeah.
this guy.
What?
You cannot declare this guy on struct.
If you have
Wait.
No, you cannot define a constructor that takes an argument on the struct.
It
It would be never
defaulted,
executed.
Yeah.
Like there's no code.
Basically, the very first time you call compress, this thing's going to have to allocate a safe handle into the covers, which
Yeah.
is what you would do anyway.
Yeah, that's what we're doing now.
But all of when you create an array of these guys, like they're all going to have defaulted to T, but they're all usable.
it's except
Well, that's-
what will the quality and window be?
Exactly. So basically,
whatever
Default
the-
values.
So let's say quality and window would be presumably fields, which would be 0. So you have to
Yeah.
handle the case when they're 0.
Yeah.
Like if you blow up because you say, oh, there have to be some value, then you're defining your struct incorrectly.
Yeah, that's not the way it works.
Yeah, zero will be default.
In which case, these guys would be gone, and
Yep.
then this one we have the same. I think it's the same API that we had on. We called it get max decoded from UTF-8 length and get max encoded to UTF-8 length.
It's wordy. But yeah, it's the same idea.
Well, we can remove IMUM.
Get max compressed size, that's
By
fine.
the way, should this take longer end?
Probably should take long. And return
Good
long.
point.
If you're, I mean, on one hand, one good argument for int is that you can create an array where the where the number of elements is an int, and then you can just create a span around that as a destination and pass it into compress. But I don't know. I could go either way on this.
Well, we don't support spans that are larger than 4 gigs either, right? Because they only have an indexer that goes so long.
It's fine because they are used for chunks, so that's
Yeah,
okay.
that shouldn't be an issue.
But this one is kind of the total size, isn't
Yeah.
it? Well, except if you use the API in the loop, you kind of don't want to call this one. It's completely irrelevant. Like calling this API is only useful if you want to complete in one chunk.
Pretty much. Yeah.
At that point, you are limited to span of bytes.
So what?
If you use this API in a loop, you would never call get max compressed size.
Because you're doing it in chunks, so it doesn't really matter what the max compressed size is, right?
If you
Because
this
you only care about this number because you want to like allocate a buffer that is sensible. In which
Yeah.
case, you don't care about what the total is because you never, hopefully, ever have to allocate that guy.
Yep.
Okay.
It's useful for the try-compress situation,
Yeah.
because it gives you exactly how much space, well, not exactly, but an upper bound on how much space you need for destination, so you know it's not going to fail because you don't have enough space.
because you're not calling it in the loop. And you,
Like, I mean, nothing prevents you from passing in like a ginormously large thing, right? I would just
Well,
basically-
it will overflow eventually.
Yeah.
Like there is a check in that method such that if the value that you pass in plus whatever the header length is greater than int32 max value, it throws.
what that would mean you cannot compress a 12 terabyte file with Brotli.
Not in a single shot.
Not with try-compress, no.
Well, that's what I'm saying. But I mean, what I'm saying is that this API here, right?
Yeah.
So if I wanna estimate essentially how big my buffer has to be,
Mhm.
then what I pass in as input size is how much I'm going to buffer, like how big my chunks are, right? So let's say that's like 8 kilobytes.
Yeah, it
Nothing
doesn't
prevents
work
me
that
from
way.
saying, I wanna estimate essentially how big my storage on the file share needs to be if I'm running broadly over the files over here, and the files over here are 12 terabyte.
Uh-huh.
So I can still call the API with longs and get sensible answers.
Oh, sure.
So I mean, like it's the same thing. It's just that if you call it in a loop, you probably don't pass in things that are bigger than in 32, right?
I don't understand. When
I'm not certain if it even works if you do it like that. I think it has to have the entire compressed size. I don't know if you can just pass it a chunk and get the maximum decompressed or maximum compressed size of that chunk.
So the way that this
That's
API
not-
works under the covers
Okay.
is it pessimistically assumes that the data that you're feeding it is not compressible at all,
Right.
and it will assume that it's writing out uncompressed data plus X number of bytes for headers. So the answer that you get back from get max compress size is always going to be strictly greater than the value that you pass in. Always.
Which kind of makes sense because it's basically giving you an upper bound.
Yeah, it's an upper bound of the
Which
final
means like
compressed size.
for this scenario, where I say I have a 12 terabyte file over here, and I want to estimate how much size I need over here.
Why?
Yeah.
If you have 12 terabytes, you don't need to estimate.
Gigabyte.
Why?
Gigabyte. Why would you need to estimate? What would you do with it? So let's say it returns 13 gigabytes. What would you do now with this information?
Well, for example, check that the output drive has that size, so I don't like run out of disk space halfway through the operation.
I don't think that's super reliable operation. You still can write out. You check, and then while you're compressing, somebody else is writing to the disk, and like you screwed. Like if you're like approaching the disk being exhausted, like it's so difficult to write software detection.
Yeah.
Experience is better when you fail early rather than later. You still have to fail later as well.
And what I would do is I would basically say whatever is the long times 1.2 is good enough estimate. Like we don't need the API for it. Honestly, this API is for the first one, for the instance method. I mean, sorry, now for the try compress,
yeah.
for the static,
That's the primary use for it.
where I just want if I don't pass enough destination for the try method, it fails.
Yep.
It doesn't actually like write. It's not like the first one that writes partially. It just doesn't write.
If for whatever reason we decide we need to add it in the future, sure, add an overload. It's not.
You only
gonna
know
make
what
this
the
any
name
less
would be.
correct.
Yeah.
It's size long.
No, it wouldn't have to be. It takes an input parameter.
Is the argument that get max compress size doesn't have
Oh,
enough
that's true.
value specifically in the try compress state that we don't want to have it?
The reverse. It has value in try compress.
So we should
Okay.
leave it in then, correct? So the question is
Leave it
whether
in,
it's
but
longer
it's an
int.
int because the try compress ones,
Sure.
they don't even deal with data sizes larger than int.
So what's the cost in having it along instead of an int, just to accommodate maybe the terabyte case?
The problem is that you get a long back and you have to cast it back.
Yeah.
Which is
Mhm.
annoying.
Okay.
Well, that's why you could do overloads if you really wanted to.
And then and if it returns a long that is longer than int32 max,
Mhm.
then you cannot create a span that large.
Sure.
So like it's useless.
You
that
can't
it-
use try, yeah.
You make it long, but you cannot use the long value.
In the try compress state, yes, that is correct. Cool. So int it is.
Alright, then you're happy with that API shape? Is that what I'm hearing?
Well, okay. So on base 64 encoder, this method is called get maxed decoded length, and here we call it size. Should we call it length?
We call it get max decoded from UTF-8 length and get max encoded to UTF-8 length. I mean, it is a mouthful.
So no, but we don't have to add UTF-8 because it has nothing to do with UTF-8.
Well, that.
My point is that I think we basically decided, I don't know if it was
Yeah.
conscious or accidental, to basically use array terminology, which is length, not size.
For what it's worth, I'm not sure if it's worth anything, the underlying native implementation uses this exact name, get max compressed size.
Not super interesting.
Yeah. That's why I prefaced it with,
Yes.
for what it's worth,
Yeah.
I'm not sure if it's worth anything.
I would base it not necessarily off of arrays, but just off of spans, and on spans it's called length. Right?
Yeah, exactly.
Yeah.
And it's used to instantiate the right size of span or array, whatever you're using.
Which basically means, if I find my fucking cursor again, I would probably say let's call this length.
And what is the parameter called?
Length.
Is it in base 64 called input length?
No, they call it bytes. But I find that weird.
They meaning us?
Sorry. No, they call it just length.
Okay, that's much
And not they, we.
better.
Why are you referring to yourself in the third person?
Because past me is
You don't want to know.
He usually does weird things that don't make sense.
Mm.
And I'm kind of upset that I know that person pretty well.
So to answer, by the way, your earlier question about what does Chrome do if it gets more data after the last
Yes.
byte block, just described it.
There you go then.
I found the check-in.
So
It was an explicit checking.
Yeah, because I was looking through their bug reports. Apparently, it was hitting an assert, so they added a check to see if there is data coming in at the end, and they just discard it.
does that mean we need an API? Because we cannot handle this right now. Oh no, we can't.
No, we leave the flush in.
Yeah.
Yeah, never mind. I'm slow.
We are golden.
All right, so then this is the API shape.
Good to me.
All right, then let's do this.
Cool.
You have to define the default constructor on Brotli encoder.
Sorry, one more thing. Do we want to discuss one more thing? Or we want to go home?
Well, I don't know.
All right, so
If you start with ubing, I want to
okay, so I suggested this thing where we use safe handle, but this stays a struct.
Yep.
There's a negative to it.
Allocated?
The negative is that if you box this thing, you're kind of paying the cost twice.
What?
If you box the struct. So let's imagine that this type, Brotli encoder, was a class. It, like, you always pay the cost of creating an object on the heap. Just like today, you always pay the cost of creating object on the heap because you create the safe handle. We could just make this thing a class, implement our own lifetime safety.
Which is to say we derive from critical finalizer object.
Yeah.
Something like this, or we implement manually. Like, there are many ways, and then you don't ever box it. So yeah, you have just one object on the heap always and always. Or we could not use safe handle and keep it as a struct, and then it's not super safe, but at least it's cheap. I think now we ended up in like this hybrid world that is neither cheap nor, I mean, it is safe, but it's not super cheap.
So I'm somewhat undecided.
What's the benefit in making it a class?
Because
Instead
then
of
you
just
can,
having this struct.
basically you don't ever box it. You always have one type on the GC heap, one object on the GC heap.
Yeah.
Well, one other benefit that you have is if you ever have to add any state to it that is not represented by the safe handle, you are not screwed. With the struct, you're always going to be screwed.
Why?
Yeah.
Now you have like 5 copies that have inconsistent configuration.
Yeah.
I see, like a mutable state that
Yeah.
you, yeah, there's maybe.
Which you get for free to make it a class. And then you also get boxing for free. You could start to have virtual methods and derive if you ever need to. Like, there's other things you can do with classes.
Yeah.
But on the other hand, it's kind of, I don't know.
To me, what I don't like about this is that it's basically, it's telling somewhat of a narrative that we're not really up for. It looks like a non-allocating covers, which at that point I would prefer to be a class, so we see basically directly that it's allocating.
Okay, so so now let's keep going. Let's imagine that we do it. Is it possible to create non-allocating Brotli encoder API?
That is safe. I don't think
That
so.
is safe? No. You would have to just have an in pointer internally.
I mean, if you're willing to AV, yeah. Well, we could do what Jared calls crazy, which is West-style borrowing or linear types or something where you can enforce that the struct is not copied around.
So
Well, I guess I should add a caveat to that earlier. Technically, we could do that if we rewrote the entire managed implementation based off the C implementation.
What would it be backed by?
Pardon?
What would the buffer be backed by? Just an array pool array?
There would be a
Also-
ton of questions there, and I'm not sure it would even work out, but it's ostensibly possible.
Also, another thing. So it's not about AVs. It's about handle recycling, correct? Issues. There's no possibility. We can detect that the.
If you go down with the managed implementation, it's still the same issue. You have use after dispose, right?
Yeah.
No. So if the handle is closed,
Yeah.
I assume we can detect it.
What you just said is if you move away from a native implementation, we make it purely managed, right? There's no handle anymore.
I'm talking about the current implementation. So it's not an AV. There's no use after free or anything like this. If the handle is closed, we can detect it because the moment you pass it to some underlying API, it will basically return an error code. The problem is that the handle can be recycled, correct? Is that the
Safe handle is secure against recycling.
if
He's
we
talking
didn't
the
use-
in-pointer
if we
case.
didn't use that.
Oh yeah, that's a terrible idea.
I know you push for and you think it's terrible. I'm saying like, what are the implications? It's not an AV and it's not. It's basically.
So one thing that we've seen before in ASP.NET when we've had stuff like this is you end up writing someone else's response to a different network stream. So say that you and you are both coming into my web server. I have an int pointer that I think is pointing to you that is actually pointing to you. I'm writing data to it, and now all of a sudden you're getting the information that was intended for you. Like that's why we moved away from them in System Web whenever we could.
And so I understand how it can work for network handles.
Yeah.
How would it work with this one?
Because if the end pointer is the buffer that I'm writing the data to, and you two and basically I've swapped end pointers under the cover so that you two basically think that you're pointing to the same structure. That means that whenever I do a flush for you or write your data to the destination string, to the destination span, I'm actually writing his data because that's what the end pointer actually points to, even though the span that I'm passing to the API is destined for you. Like, because what I'll do is I'll get an array pool or stack-alloc or something. I'll have copied the data into there, and then I'll pass that span over to your network string.
Okay, so I understand. So another question related. So as we talked, those are not real Windows handles, correct?
Correct. They're just
They are just
they're memory
pointers.
addresses. Yeah. And that's what makes this a little bit more insidious too, because real handles you can kind of detect. Like memory addresses are reused all the time, right? Because that's how malloc and free are optimized under the covers.
So how do handles in Windows work then? How do they know that the value is valid? They have a hash table on the side that basically says this is a valid.
How does safe handle work?
Well, no, Windows handles themselves. I mean, if I pass them a random in, they don't crash, right? So
Correct. They do have their own map of which handles are valid, but they do sometimes reuse numbers in that map.
Which means that you can get to the point of writing to
Yes,
someone
you have
else.
recycling issues, but you never have AV issues, right? If I'm passing a random value, like
It
worst case is-
depends. It depends on what API you're calling. Yeah.
Okay.
Like if you're calling a kernel API and passing it a bad handle, it won't AV. Well, it won't bug check the machine. But if you're calling like bcrypt, for instance, and you pass it a bad handle, yeah, you're going to AV.
Right.
Because that handle is actually a memory address.
Yeah, I guess this is basically the same reason why we have owned memory.
Okay. But again, safe handle is fine for this because safe handle has its own ref counting. So if for whatever reason somebody tries using one of these after it's been disposed, safe handle will kick in and throw a proper exception at the right point. And it's all thread safe too.
No, I think that
Does it have ref count?
It has its own separate ref count.
Just like handle class.
Until finalizer, basically? Or
Yeah.
Okay, so I think now I thought about something. So this is very similar to how memory of T and owned memory works and the reasons for their existence. Owned memory basically is a class that wraps native pointers such that when you pass memory of T around, you don't end up with the same issue, and memory of T is a struct. We used to have a feature in memory and owned memory that lets you reuse the internal type, owned memory. So you don't pay the cost of allocations. Okay, so here's how it worked. When memory of T is created for owned memory, in your case, when Brotli encoder would be created, the struct, for given state, like the handle, we would give it a GUID. And then when it's disposed and reused, the internal object, we would give it a new GUID. And now if your struct tries to access the class and the GUIDs don't match, it throws. Basically, this is how it detects.
Like a canary almost.
So we decided not to do. Basically, we removed this feature from memory of T, and I now regret. And we removed it because we were optimizing performance of Kestrel, and we were just removing everything that we could because we had problems meeting the
Pretty
performance.
freaking heavyweight. I mean, they have like what, 16 bytes, for instance, or something?
Oh.
Width?
Well, so it was actually okay. So initially it was a GUID, and we just put a long, and then Vance said we could even make it like an int, and it would be so impossible to hit that. Like
Your birthday paradox, like you only need 65,000 instances before you get a collision with an int32. So
65,000.
2 to the 16.
But why?
Birthday paradox.
Oh, because on both sides.
Yeah.
Sure, but so for at least for memory and owned memory, it's more like a. I guess maybe there's some security aspect of it, but it was more about like developers not shooting themselves in the.
Yeah, but what are you going to do? Like fail fast if you see it?
Oh, we'd say object disposed, just like we say today. Like if you on memory of T, if you dispose the underlying memory, we throw object disposed.
Yeah, but if you throw while a web request is being shows an error page, like you haven't actually fixed the bug in the application. It will eventually manifest itself.
Someone can reuse it,
Sure, but-
use it, misuse it, right?
Okay, but that is current behavior. Like you can dispose the memory, and if you try to access it, it will throw object dispose. There's
Yeah,
no
but
escape from it.
it makes it a little bit easier to get into this if we start reusing the objects behind the scenes now.
No, why? If you disposed on memory, all memories of T today will throw object dispose.
Yeah.
Whether you then subsequently reuse the owned memory, it doesn't matter. Like they will all throw.
I thought you were talking about reusing, and maybe I misunderstood what your scenario was on.
If you reuse, then some of them might not throw.
No, they will because they have the old GUID. So if they try
Well,
to
but if
access-
you get collision on the GUID,
yeah.
which is on, and int is going to happen one in 64K.
Well, a collision on int32 will happen. Will happen like once every 65,000 times. A collision on GUID's going to be a lot harder to get into.
Yeah. So anyway, but the point, what I was trying to make is, you said something that, not whether you have a collision, that it somehow impacts security of a web server.
I
was saying
I wasn't making a security argument. I was just making a reliability argument. Really. Like this, we don't want to be in a situation where a bug could manifest itself just by an exception being thrown and swallowed that the developer wouldn't have really seen while he was debugging. Or better yet, we would probably want this to bring down the application if it occurred, because it means something's gone horribly, horribly wrong.
But
It's basically an AV.
So say it again. What you would not want to happen?
So what I would not want to happen is the behavior right now, because we actually have, like, it sounds like we have an actual object which is disposed under the covers.
Yeah.
If we try using that, we know that the object's disposed because we probably have an isDispose field.
Yeah.
And we can throw an exception, and we tank that request,
Yeah.
but we haven't negatively affected anything else aside from that one request. if we start reusing these instances instead of having a disposed field, if we just use like a canary or something like that, then what happens is we will eventually get a collision, which means that where we expected an object disposed exception to be thrown, instead the code will succeed and have undefined behavior.
Sure, but I think if you have code that like does something with this exception, like it's a bug. Basically, it's a bug detection mechanism. It's
What
not,
he's saying is that like the problem is you can get lucky.
and
You might only ever
don't
see it
get an
under load
exception.
or under stress.
Yeah.
what the exception?
Yeah.
Okay, so what? So you see it, yes, only under load.
Yes, but this means that your application, you have 65,000 requests over the course of a day. 65,000 minus one fail,
Yes,
and then one of them succeeds and does random things.
correct. But I'm saying if you have the 65 that don't succeed,
Yeah.
either your server crashes or you have some code to handle an exception which is just a bug. Basically.
Yeah, but normally that exception handling code is just like show an error to the user and maybe file an automated ticket with IT.
You basically just fail that particular request. You don't fail the entire web server.
Yeah.
Oops.
I would prefer to see like literally an environment.failfast if we got into this.
Instead of object dispose. Yeah.
Which I would argue seems reasonable. Like if you want to get a crash down, you want to get it literally at that point, not
Yeah.
like after somebody caught this guy.
But the problem with failfast is
orthogonal because we basically have it in
Yeah.
all the bases. It's still I feel like it doesn't change that like you don't have a fundamental problem with the canary solution. And I think we could use it for some APIs like this to optimize for performance if we cared. I mean, for memory allocations if we cared enough.
I mean, why not just have the application pool it?
Pull what?
Instances of the encoder and decoder.
Well, then you have don't you have exactly the same problem that you're trying to avoid?
Pool instances of the encoder and decoder?
Yeah.
You have exactly the same problem.
No,
So-
what I'm
Logical operations can have now
Which
a reference
is-
to the same.
which is fine, but the application developer has made an intentional decision to do that. Whereas the class design just assumes you create the encoder, you encode some stuff, and then you dispose of it. And if the application developer really wants to go crazy and pool them, he can, but he's responsible for lifetime management.
Great pool, anyone?
Yes, that is the same class of problems.
Well, array pool.
We provide it as an API, which we make it even easier for people.
No, but array pool is not good for it. Because array pool is a pool of arrays, and you just want to pull individual of those. You don't want an array of encoders.
No, not an array.
No, but list, whatever.
Do we not have like a regular
Object pool?
object cache, object pool API?
We don't, but we should.
I mean, Rosen has their own like pool.
I think there is something in WCF, if I remember correctly.
There's everything in
I think
WCF.
it's safe to say that whatever that looks like, we don't want that.
There's some pooling API.
Probably inefficient. Would be my
It's
guess.
efficient for WCF purposes.
Which is already like through the roof. So yes.
Hi, Matt.
Okay, I buy the argument.
We should play with that API then.
Just
If
saying.
somebody cares enough, maybe they should use pooling.
So how?
That means we have to have the encoder and decoder be reusable if we want that to work.
That's not really doable.
Okay, never mind.
Well, it carries a lot of state. Once you write the final block, you can't give it more data. Like
So
for,
why can't it-
compression or decompression even.
No, so, but I think there's, like, maybe that's how the underlying native
That's true, yes.
API works, but why couldn't it work the following way? You write a bunch of these chunks, you say final, it writes the final, now you can start writing new chunks and they belong to a new kind of sequence. And then they can have final at the end and you can repeat the cycle.
Sure.
No, that's not the way Google
That's
wrote the
not the way
implementation.
that-
Yeah.
We should file it.
Well, I mean, what do you do in constructor? You go to the native API and you get like an init or something. You get like the root object, right?
Yeah.
Just replace that.
So you would just say when we write finally, you basically free the underlying memory, and then remember that you don't have anything. So if people write, you just go back to the implementation and ask for the next thing.
That's something we could do, I suppose,
yeah.
if we want to just restart the whole
Yeah.
object. Then yeah, that's
That's what we're
possible.
saying. Which means
Oh, okay. I
you don't
thought you were
have
asking
to-
if you could reuse the native
No,
one.
you don't have
the
to
native
allocate
handle.
our object. Like there's the cost associated down, right? But you would have to pay it either way.
Oh,
If
no,
it's
no.
struct or class, doesn't matter.
So what is the cost of our object, though? It's a struct, right? And it's got
It's
one field in
allocation.
It's
No,
the end pointer.
it's about no allocating. But like if there's some native cost already,
But you're allocating again, right?
Yeah, I was thinking about reusing everything.
Yeah, we can't reuse everything.
You allocate.
The only thing we can
Fair enough.
reuse
Just don't see because it's a struct.
Yeah, that doesn't make any sense. Unless we can reuse the native memory.
which we cannot today apparently.
Supposedly we cannot. Did you actually try it, or you?
We'll double check, but I'm fairly confident you can't.
Because that seems like not a very Google design.
I don't know.
I mean, come on, like, why would I assume the structures are kind of expensive, and you have to allocate them.
They probably have their own custom allocator.
You have to allocate a bunch of native memory because you wanted to write EOF. Like that sounds not super frugal.
But have we measured that these allocations are even that impactful to performance? Like, wouldn't just the sheer CPU cost of compression outweigh everything?
That's kind of what my results have shown. Yeah, I have it where we have the non-allocating one, the struct one that just uses an end pointer, and then I have the one with the safe handle, and then I have try compress fully or try compress, try decompress or whatever, and they're all very close. The fastest is the try compress, try decompress, followed by the non-allocating.
Do you know what's the size of the native structures that it's allocating?
Not offhand.
16.8 bytes.
Yeah.
It's like this many objects.
Well, doing internal heap allocations that we wouldn't see, right?
It does.
Yeah.
Yeah.
So we see maybe a 32-byte structure, but it contains pointers to.
It does. It allocates several times for the windows.
I mean, and also like so measuring performance differences in like allocating non-allocating APIs is hard because if you don't have lots of threads and a lot of pressure on memory, they're not gonna be very different.
Yeah, they're pretty much all.
Correct. It's only starts showing up if you have like taking power, benchmark that basically like does things like crazy. Imagine in every single taking power request, like 1 million per second, you allocate like some massive internal native data structures. And basically, if you have a stateful object that you cannot reuse, you would have to do it.
I mean, you could also do try to compress and avoid that problem.
How? It doesn't create underlying data structures underneath?
It doesn't create nearly as much.
I see.
Oh, really? Why?
It doesn't need as much if it knows it's only going to do it in one pass.
Which means